showed us a picture on his PowerPoint that was like the gate was like this, and it comes together like this with like these little things, and then when it comes out, when it hits, the action potential hits it, it goes like this, like that, and then it opens in that.
Oh, okay.
Like it uncorks it, like
yeah.
that.
Mm-hmm.
Well, that's not a really good picture, but.
Well, I see what you mean though, but this was explained to me, like it kind of like pops it out so that it like spills out this calcium, right? Mm-hmm. But what you're thinking of, the reuptake, is called a circa pump. Did you learn that? Or ATP?
Yeah, ATP pump.
Yeah. Yeah, circa.
And if the ATP pump was broken, then it would cause it to just never break off and do that.
More contract.
Yeah.
Yeah.
Right? Because when you have calcium and ATP, muscle contraction, right? That's like the equation, right? And if there's no reuptake of the calcium,
and it never breaks off.
Then so then you can get like.
We're just trying to think of all the test questions they're gonna ask.
Yeah.
If this is broken, what's gonna happen?
Yeah.
So
this is run by ATP, right?
Mm-hmm.
So it requires energy to pull calcium back in, right? This also helps balance the amount of calcium, because you don't necessarily want to dump calcium in there as much as possible. So this is always going, but this opens and closes. So when this opens, it comes back out, causes muscle contraction, but it's still kind of going.
So if it never gets sucked back in, then calcium just accumulates and always jumps on the.
And so you'd have like really intense contraction. But this is run by ATP, right? Causes energy. I bet you there's going to be a question on rigor mortis. Were you talking about that?
Yeah, when you die.
So how would you explain rigor mortis?
The ATP pump is no longer working, so it can't suck the calcium back in, so it just stays.
You die and you can't do it because it's stuck.
So there's two parts. You're going to have calcium levels will be really high. So tropomyosin will not be covering the active sites, right? So you have active site binding.
It does move then, right?
What?
So I was when he explained it to me, my immediate thought is that your body goes like that, like moves, but he just made it seem like it just gets stuck like that. Like if you're in this position, you're stuck. Like that.
It's probably more that.
More like that.
Because
it doesn't
I'll explain why. So we've got calcium present, right? But then we also have no ATP. So did you guys go over like the cross-bridge coupling thing?
Uh-huh.
What part of that is, what does ATP do in that process?
It releases.
Yeah, so it releases, right? So for muscle shortening, right, we need constant like releasing
so
like
no
this.
Longer be releasing.
All it would do is it would stick, and then ATP would run out, so it can't unbind. So it would just stay there. Does that make sense?
Yeah. Is there? Okay, this is a problem. I just thought I saw on a show like when bodies sometimes like move or whatever when after they're dead.
Uh-huh.
Is that part of rigor mortis?
I'm not sure, because honestly, like your body is constantly producing ATP, but it's also constantly using it. Like if you were to stop producing ATP right now, you would live like 5 seconds. So like that's how fast you're using ATP, right? It's just like pumping it out, but like you're constantly using it, right? And so if you were to die, you would stop producing ATP, right? Mm-hmm. And so the chance of somebody moving like a long time after they died is like, I don't know how likely that would be, because you'd run out of ATP, and you need ATP as a part of every process, you know what I mean? So that's why if there was any shortening, it wouldn't be like, because that would use like way more ATP than you even have, you know what I mean? And so it's kind of like, it would probably just like stiffen, you know, more than actually like a concentric contraction.
Okay, it's a little off topic, but, well, kind of. When, does the muscle move right when the the actin and the myosin connect, or when the phosphate falls off the ADP?
Yeah, it's during the power stroke. So that's when the ADP, right, comes off, and then it does a power stroke, right?
I just like exactly when it moves. Is that right when they connect, or is it when the
No,
ADP falls off?
it's when the myosin head does this, the power stroke, right?
Yeah.
Because basically it's looking like this, and so when it makes a connection, it doesn't shorten anything. It does this, and then it goes like that.
And what makes it cock is the ADP falls off.
Yeah, so what we have is when it makes the connection is when phosphate comes off, right? Then ADP falls off,
And
right?
that's when it cocks.
Then
It makes
that's
the
when
move.
it, but then ATP binds, so it goes off, and then the breakdown of ATP causes it to recock like this. And then it binds, because phosphate comes off, then ADP comes off, boom, does that. ATP binds, so it lets go, breaks down ATP, recocks. Like, so it kind of get confusing because you'd think that it uses ATP when it does a power stroke.
Mm-hmm.
But, so this whole cross bridge thing, the way that helps me remember it is basically myosin wants to bind to actin, right? And the components of ATP, so the phosphate and the ADP, get in the way. And so when it first binds, it needs to get rid of something to bind, right? So it gets rid of the phosphate, so it binds. But then it wants to bind even more, like all the surface of the myosin head wants to bind. So it has to get rid of ADP, so that pops out. That's what causes it to bind, right? But then ATP comes in and has more affinity for the ATP than it does to be bound to actin, so it releases, so it can bind to ATP. So it's like it's competing for space, right? It can't have both, right? And so it gives up one, right? So, okay, I've got ADP and phosphate, so I'll give up phosphate and bind. It's like, oh, I want to be all the way bound, so I'll get rid of ADP. And it's like, oh, I really want the ATP, so I'll unbind so I can grab that, and that cocks it back in the other position, type of thing.
So does that make the full movement, or that's like a billion of them happening? Just
Yeah,
getting it?
yeah, because when you've got these like these sarcomeres, right? You've got like we're talking about one myosin head, right? But we've got this thing with just like millions of these myosin heads coming off this way, and then you've got these actin filaments, right? Kind of like this. And so this is happening at each one of these, and not exactly at the same time. They're like kind of going like this. And so it creates kind of like a smooth contraction.
Okay.
And what is it? The tryptone's the one that actually moves it, or like shortens it.
Troponin,
Oh, the
Titan.
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 The only thing that actually moves in it.
The Titan pulls the actin closer to the M line.
So this is actually kind of debatable because this is like the best explanation of muscle physiology, but it's not perfect actually. Titan is actually, from what I've read, the most current research is more involved with eccentric muscle contraction. So concentric is when you're muscle shortening during contraction, right? Isometric is when you're contracting but the length doesn't change. So it's like
Posture.
yeah, or like if you like to flex your bicep but not move it, it's contracting, but so we're making cross bridges but they're not like
Moving.
yeah. So, but then you have eccentric. So that would be like contracting your bicep and pulling your arm down. So my bicep is contracting, but it's lengthening, right? So that's the kind of thing where, so we've got lengthening but contraction. So like how does that work? Because with the actin myosin, they're pulling towards the center, right? And pulling things in towards each other. So we've got contraction, but the muscle is lengthening. So it's like, are these myosin heads like ripping off the actin? So what they think it is Titan, right? So what Titan does is it's kind of like a springward force that wants to keep it short. And so when you pull it apart and lengthen it, it creates tension, right? And that's kind of what Titan is more involved with, is eccentric muscle contraction. But I don't know, did he define it for
You
you?
said a quiz question, and then it
Yeah.
said
Really?
Titan was the only thing that moves.
Yeah, it said what lengthens in a muscle contraction? Myosin, actin, Titan, or none. of them. And
Oh,
so
really?
it was like Titan was the thing that was like a spring that moved. The other ones don't lengthen.
Oh,
They,
yeah,
or
that makes
shorten.
sense.
They stay the same.
Yeah, because through here, basically, like we've got our Z discs, right? And so, yeah, these two things, they're not getting longer or shorter. They're just going like this. But Titan kind of like spans all the way across, kind of goes like this. And so it is actually, when you pull it apart, it's lengthening. And when you pull it closer, it's shortening. Does that kind of make sense?
Yeah.
So, yeah, that makes sense. So it's these two things. They're not getting shorter or longer. They're just getting closer, pulling towards each other.
Mm-hmm.
Right? So.